everyone. Welcome. My name is Isabella. I'm here with Mark, who is our founder and CTO. And today I'm really excited to talk with you guys about vector graphics. And this is going to be the first on a series we're going to do around the graphical components and functionalities in general, not only about our software, but about the graphical space in general. This should be a quick intro, just like I said, Vector Graphics 101, Vector Drawing 101, and then we'll get into more of it in the following weeks as we wrap up the year. So first things first, if you have not subscribed to our channel, please do so. We're always open for your suggestions as well. So if you do not, if you haven't connected to us on Discord, you can also do that. I'll put the link on chat, but you can also find it on our website. Like I said, December we'll be focusing a little bit on the graphical space, but we're always looking for suggestions. If you have anything that you would like to see, let us know. So yeah, let's get this thing started. Like I said, this should be a quick intro to the space. So Mark, give us an overview. And as I'm here, hello, Dan. I see you as well on chat. Good to see you as usual. So go ahead, Mark.
Well, let's start with some basic concepts. When you organize your HMI, you can organize in what we call a canvas. It's essentially a drawing that each element, they have a specific coordinates, or you can organize as dashboards that are many cells or grids where each component of that grid, that by itself can be a drawing. In this training, you're going to go to explain the basic drawing that can be either a cell in a grid or the entire page. Explain the concept of canvas and what means that drawing. From the early times of HMIs, human-machine interface, we have those concepts of coordinates. On the past, that used to be the pixel resolution. When you work with vector graphics, those numbers, they are no longer the resolution. Those numbers are the coordinates of your points, of your elements. So you can help me, Isabella, explain the difference between the vector graphics and raster graphics.
Yeah, so for those who don't know, whenever we're talking about images in general, we're talking about raster graphics, the pixels. So when you see an image, they're a little bit, they're made of small little images, which we call pixels. And those are great for details and things like that, but they don't translate well when we're thinking about increasing or even decreasing size. When you increase a lot of something, that it's a pixel, you get pixelated, as the name suggested. And when you're talking about graphics, really you're talking about math. Those are numbers. They're not even images itself. They are drawings made out of mathematical equations, is the science behind it. And the awesome part about that is that you can really increase it as much as you want. So obviously, if we're thinking about the industrial space, that you want to go with a great array of resolutions, that is where you want to go. You can do a little less detail, but do not let that stop you. Gone are the days where the vectors had to be simple and very simple shapes. Now you can play around with it. Mark's showing something that is a vector drawing. He has a bunch of different parts to it, and they are all vector. So that means we can increase that as much as we want.
Exactly. So if that was an image, I'll not be able to pick up, as I'm doing here, piece and parts of the vector. So it's not only about being able to be resolution independent, but it's also to be able to modify more easily the layouts or even apply dynamic properties. So if I'm doing some sort of HMI application that I want this specific piece to change colors or to have a dynamic behavior, you can act in each one of those elements. But let's start with something even more basic than that, that are about those coordinates. So let me delete all those elements.
Perfect.
When you have your display, as I was explaining, those numbers nowadays, they are no longer resolution. In general, those numbers, they are related what would be the typical size of the image when that image is printed. And most of the monitors nowadays, they have a resolution of at minimum 96 dots per inch. What means dots per inch? It means that if you create an object and this object, you make the size, let's make the width of object 96, and let's make the height of that object also 96. You have now these objects that when you print these objects or when you see that object in a typical display, that width will be 1 inch. That's what those numbers means in general. That means if you create a display of size 1300 by 700 or 2600 by 1400, doesn't matter really. What is important when you create your display is one concept that called as aspect ratio. That's the difference between the width and the height that will define what will be the best visualization for your diagram, for your machine, for your equipment. So if you are doing, if you are defining a display with those coordinates, or you multiply the double, they both will scale very nicely in all displays. But there is a reason we like by default to do those two magic numbers here. Because to most of the displays, when you create a resolution with those numbers, you have a good look and feel on most monitors what will be a good visualization for the operator or not. Help me explaining in little more detail that concept, Isabella?
How do you want it? What concepts
About
exactly?
those size, what that size means, the
Yeah,
size of the display.
yeah, you're thinking, for example, when you think mobile, you want to make sure, like Mark mentioned on the aspect ratio, you got a bigger height that you have a width. And usually, when we think about certain displays, they have specific numbers for that. It's going to depend on your application as well, but just like for an example, a width of something like 800 pixels, that is a normal width that we use when we're thinking about mobile layouts. So you want to consider for example, if you have a big desktop, a big monitor where you're looking at your dashboards and your displays, you want to put in a similar width to that, so you get the best visualization possible.
And let's give some specific numbers because it's vector graphic and is scale precisely.
Yeah.
Scaling precisely not necessarily means it will be nice and visible to the human eye, even scaling precisely. So if in this example, this drawing tool, that's a FrameworX, you can very easily specify the zoom level.
Yeah.
When you are looking or design, you can scale in and scale out.
Mm-hmm.
So 100% means you're not doing any scale. You see the image, what you call in the original size.
Yeah.
And you see when you are doing this resolution, that's the G4 of the product, that is give a very good impression on how will be that display when you put in a typical notebook computer or a typical 14-inch up to 20-inch display. So if you do a display that in this resolution your elements, they are aligning properly, when you are in that 100% resolution, or if you want to see the entire view of the display, how they look like, but the operator, you see that display at 100%, you have a good idea on what to be that look and feel.
Perfect.
If you are creating an application to a control room where I'm going to have a 4-inch display, if you use those coordinates, you can scale up, but it does not give a good drawing feeling for you.
Mhm.
So if I were to draw an HMI to display in a very large display, would make much more sense put a number like 4,000 here, because remember, you can think about 100 as being more or less 1 inch. So if you have a 40-inch display, if you put the number 4,000, you have a good look and feel what's reasonable for the human eye to see in that large display, to have the entire resolution of that display with good optimization.
Perfect.
Because you have such a large display, you can have more elements to better use your large display.
Yes.
And on the other hand, that's the example Isabella gave on a mobile device. If you have a mobile phone, you can have big and smaller models, but it's fair to say that a typical mobile phone would have what, Isabella, 10 inches, something like that?
Yeah, we
No
usually
more
go
than 20?
800 pixels. So,
Yeah.
but you can do 1,000.
So it makes much more sense if the drawing or display that's targeted to be in a mobile device, you should put those numbers. Okay. Again, even you can zoom in and zoom out. The initial number that you define gives your visually on your computer display a good look and feel on what will be proper on that device. So if you are designing a display for mobile, your starting point should be a display with 600 or even 500 by 1000. That's a good number. We do a recommendation. So you have a good look and feel on what looks nice in a display. And let's review some basic concepts, Isabella, on coordinates, grids. Go to our checklist there, and I show here. Let's review some naming conventions on vector graphics to our group.
Cool.
You tell me.
Do you want to talk grids, or do you want to talk a little bit about some
Well, let's start
common
with
patterns for industrial drawing?
Well, let's start with grids. Why not?
Yeah, I think we can talk grids and then go over some formats.
When you are doing vector graphics, that is that base concept. Let me turn off that grids. That everything you do will have some coordinates, and those coordinates, typically you define the left and top position, and you define the width and the height. So in vector graphics, you have always those 4 coordinates, these points plus the width and the height. And when doing many objects on the display, you want to have them aligned. There are a few ways to find that. One way is to select those many objects and define by brute force all the objects they have the same left coordinates. And you see the ones you have the quotes because it means each one has a different number here when you have multiple selection. Another way to do that is define those elements and ask them to be aligned by the center or by the left. And another way is to enable the grid lines. The grid lines allows you to have the visual position of the objects. So when you are doing your positioning, you can define that objects should be aligned to the grids. You can do that manually or using one concept that's called snap to grids. So snap to grids, when you enable, when you move the objects, it will automatically, as you see, move in jumps. So the objects will be automatically be aligned through those grid lines. That's another way, very common. And the reason you need to know all those features is if you're doing a bunch of input fields, you may want to have the grid lines and they snap to grids. So if you put here a text box, it will be automatically and very easily be aligned when you move. Yes. But at the same time, if you are defining a machine, you are defining a plant floor or defining a technical drawing, you don't want to have that constraint. So you may want to get completely rid of the grid lines, or at the minimum, don't do that spacing anymore, okay? And another name you need to know is called a thumb. A thumb is this little square that shows when you're in the graphical editor which object is selected. So if you are working with high resolution or two-man place, sometimes it's useful to control the thumb size. So to explain what is a thumb size, I'll put here a very big number so you can see what is the thumb. So the thumb is what you get when you are etching those elements. And if you have a polyline, like that one, the thumb size is also very important because when you select to modify a polyline, you can get each one of those thumbs to add, remove, or modify the lines of your polyline.
That's perfect.
What else in concepts and names, Isabella?
I would just say this is important to have that precise, have that millimetric precision when you're building things like anything in the industrial space, really. Like Mark said, sometimes you want to be a little more open if you're just drawing some diagrams, but if you're building something that's meant to represent something in real life, that is specific and alignment, that really matters. So that's why
That's why you can double click and see exactly.
That's perfect. Yeah.
The coordinates of our points. Especially now using AI, you can ask the AI to create those shapes for you.
Yes.
And you just copy and paste those shapes. Or you're going to talk later about graphical formats. You can also import that directly, okay? But one example, we ask the AI to create a star, or we ask the AI to create a cloud. So those objects that you see here are vector graphics that were created by AI. And when you double click, by the way, let me put this thumb size smaller.
Yeah, a little smaller.
It was very distracting. And you see, we have in those objects, you have the shape of the objects.
Yeah.
And by the way, now it would be a good time to introduce some basic concepts of polylines, shapes.
I was going to say, let's think about what are the most common shapes and things like that when we think about vector graphics.
Yeah, we have, of course, the rectangle.
Perfect.
We have the circle. we have the ellipses. By the way, ellipse and circle are the same objects. If I pick up this ellipse and I resize, so they have the same width and height, now it's a circle, okay? And we have the polylines. We have also the closed polylines, okay? And then we have also I will talk about those curves a little bit, but we have one concept that's very important. That's a combination of elements.
Mm-hmm.
When you have two elements like that, you can combine those objects and make what you call a group. When you have a group of objects, they can reside together, but there are still two objects. It means you can still pick up each object independently. You can modify the colors of each object, just grouping objects. But there is another concept that you do in vector graphics, which is to combine objects to create a new object. As you saw now, I created one object that's composed by the union of those two objects. Or I give you one more example. I'll pick up this object here, this other object here, and if I combine those two objects, again, doing a union, I have something similar to a motor or an industrial symbol. Or if I do, instead of a union, I do an exclude, I have now something more similar to the old Pac-Man. So this is a new object. And the name of that combination, it's not very nice. In Windows Presentation Foundation, many graphical APIs, they call that a path.
Yeah.
So it's not the best name because confused with directory, but it is what is. It's a path. Mm-hmm. So this object is a path. And a path is a representation of a combination of objects or lines. So let me give another example of path. In general, we call shape path to avoid the confusion with folders. But a path can be, for instance, a Bezier. If I do like that, I'm creating a polyline. If I select these other elements, very common in vector drawing, I select the points, but then I ask the system to create a mathematical curve called sequence of Beziers, or the final curve is called a spline, where the system modifies to modify the drawing to give a natural line to the points. As you have a chord or some element, it creates a shape going through the points to give a more natural look and feel. Yeah. Each segment is called a Bezier, and the entire line is called a spline. What else on that one, Isabella?
I would say it seems simple, like we're talking about squares and circles, but that is the base of pretty much any vector drawing. A lot of the symbols we're going to see and that you can find in our product, that's all they are. They are a combination of shapes as simple as just rectangles that have been cut or joined. So it's important to understand, so you can build your own graphics if you need to. And like Mark said, you can give specific dynamics to little pieces of it, which is the magic of the vector drawing.
Exactly. And also that very important concept of combining, that you have two ways to combine elements. You can combine vector graphs to create a new element. So this one is one object. This is another object. And if you see the details of those objects, when you see a polyline, it's very simple. The polyline is composed by points. So 0, 0, the first point, then 149 is this point here, then this other point is this other one. When you have a more complex combination, you go to another syntax that additional to points, they can have drawing paths. So the name path came that we start with a medium point and 10, 10. Then you have a circle on them, then you have a Bezier. So this type of notation are explaining how you can draw Bezier curves and lines using this graphical notation. What, by the way, that's a graph notation used on SVG files. But the graph notation itself has a name, Isabella?
I'm not sure, but I think this is a good place to talk about some formats.
Yeah, because this graph notation is used in many environments. It's used in Windows Presentation Foundation, this drawing tool, to do the representation of those complex lines.
Yeah.
But it's being used also inside some other graphical formats. And I believe when you talk about images, there are three types of images you need to learn the names. So if you go here to images to import a file, and you see there are many extensions that your file can have. And you need only to know that are three types of files. That's simple. Many of those extensions, PNG, JPEG, BMP,
GIF,
GIT, ICO, WP, they are all image files. And explain a little bit what image or raster is to the group, Isabella.
Yeah, that's what we said in the beginning. Those are made of pixels and not points. That means for sure you can import, but they won't translate as well if you are increasing the size of your resolution. And most important, you cannot break them apart. So you cannot give specific dynamics or animations to little pieces of it the way you can do with vector graphics.
Exactly. To do vector graphics, there are only two formats that you can do, that are the SVG and XML. I will start with XVG, that is the one that is common. When you bring a SVG file, let me delete everything here.
Clean everything.
Yeah. So when you bring a SVG file, that's the most common format. And let me write those names also here. So who are looking through the computer, it has those names. So the two vector files that we're going to do are in those drawings are SVG or XML. And there are other type of vector graphics, 3GS, the extension for AutoCAD, the GWG. So don't misunderstand me. There are many other file formats that are vector, but cheap, they're not using on the HMI drawing.
Yeah.
So here
for those who know, for those who know graphical space, you're going to have EPS or AI, which is just Adobe Illustrator. Obviously, those are vector formats, but not something common for
not really
industrial space. Yeah.
And there are many tools and AI tools or free online tools. They can migrate those graphics to any of those two formats.
Yes.
So the end of the day, when talk about having your library of drawings or apply on the display, we're going to use one of those two. And when you bring one of those two to the system, it means you can break that apart, or you can pick up pieces of that and to modify. And in fact, you don't even need to break. Using this icon, that's a direct selection tool. You can even modify elements or apply dynamic properties without having to unbreak the symbol. Or when you break, you still have the many components that create each symbol. So the benefit of using those is not only they scale properly, but especially in real-time animation, you can apply specific properties to any parts of that shape. What else in basic concepts, Isabella?
We talked about formats. We talked about the basic shapes. I think it's worth mentioning just real quick what kind of things you can build with that. So we're thinking about diagrams for a process for sure. You can build your own icons using those shapes or creating something visually and importing as a SVG. I will make a note that we have our own symbol and even icon library for you guys. But as we're thinking about things you guys can create on your own,
Yeah,
that's
in fact, if you install our FrameworX demo, you can do, for instance, like this one, you
yes,
have the full, and it's very interesting to mention your real life application in general. The most advanced application will be a combination of vector graphics and images.
perfect.
I think that's interesting to mention that also. So if I pick up this application as an example, this machine was created. If you try to do this machine only in images, that's not very nice because you cannot do the animation to have those bottles running. I, I don't do it now online. It's homework to install this demo and have the machine running.
Yeah.
But so I need those bottles to be a vector so they can move around the machine. But at the same time, the drawing of the machine itself would be very time consuming to try to do in pure vector graphics. Because one nice thing about images, you can capture, you can scanner, you can take a picture and start from the picture. And there are many nice tools to do images. So
Libraries as well.
libraries. So let me create a new display, copying that image to that new display. So I have only that image there. So when you have this, oops, wrong image. Let's go here to my main page and get the image I want, this one here. So copy and go to my new page and paste that image there. So this is an image file.
Perfect.
It's probably something someone took a picture or a screenshot from a machine catalog. And instead of recreating that in vector graphics, they just overlay some objects in top of that image. That's a very common practice when designing some more advanced UIs.
That's perfect.
And we are going to talk next week in the many type of transformations you can do with those vector graphics. Because the vector graphs, not only they scale nicely, but you can do many type of transformation of that objects. You can change how is the look and feel and the color of the borders of that objects. You can change the internal feel of that object, how it will be. You can also apply many vector transformation, like 3D projections, like I'm doing here.
You have to.
That's called a skill transform. You can do resizing. There are many transformations you can do with a vector element. So next week, we're going to explore how you combine those shapes to create more advanced objects, what kind of transformation and dynamic behavior you can add to those objects, and how to control when you resize the object and you resize the window, how they will behave. They will expand all of them, or they will expand on the width, the height. You also explore to give more control on how those objects will behave when they have their size changing.
Perfect.
And that will be next week.
Yeah, I
Any
was gonna.
final?
Yeah, I will ask if you guys have any questions. We talked about doing this a little bit shorter, just to kind of, like I said, intro into vector drawing. We'll have class 102 next week that goes into a little more detail and also how our tools can help you with that. I think I will go over some good practices and best practices when you think about vector drawings to kind of end. But if you guys have any questions, please throw them on chat. And Mark,
Okay.
I think just real quick, if we think best practices, just for this, I think it's worth mentioning that you want to make sure that your vectors are clean, no unnecessary points, things like that. Because as you draw, guys, the best part about using graphics is to have something that's clean and that you can play around with. And the best way to do that is to have something that does not have any unnecessary data. So keep it clean, no unnecessary curves. Make sure we'll talk more about that in the future, but your borders are clean and they have it as a width that you make sense for what you're drawing. You also don't want to have enough, no loose points is what we call them, is when you don't actually close anything. And also make sure that you're building things to make it easier for yourselves that you can utilize again. That's why we have our library. So we give you guys a bunch of symbols and elements that you can use again and again. So it's easier. But if you're going to draw something new for yourself, think about that. How can I use that elements in different places in my diagrams, in my HMI screens, whatever you need.
Bottom line, you need to have the user and the functionalities, what you try to accomplish, very clear.
Perfect.
And do the UI for that. And we'll cover in the next few weeks the details of the library. But if you go to our library, you'll see that we do have some objects that are very rich, because in those cases, you want to have as clear as possible copy of the real world object for whatever reason, but you want to have something that could give a good visual to the operator. But at the same time, in some of displays like this high performance HMI library, you see the representation of the objects here are very clean and very simple, because those elements, they are designed for SCADA operators. And you don't want to put unnecessary details here. You want to put a very clear and simple, in many cases follow ISA standards to be the representation. So this training that we did today and that we'll do the next few weeks is to give you all the skills, understanding how you can play with those vector graphs, how you can create, how you can modify. Yes. Then you go to your specific on your application to decide when you need something rich and colorful, where you need something simple, where you need to follow a standard, but you have a very clear understanding on how you can create, how you can modify, how you can put dynamic behavior in that set of objects to create reusable and useful components.
Beautiful. So yeah, like I said, let me just give some last notes. This was the first on a series on the graphical side of stuff. Vector drawing 1-on-1 was this class. So next week we'll get into a little more detail, talk a little bit about some other tools, how you can make your vector drawings more complex. If you have any suggestions, let us know. If you don't follow us on YouTube yet, make sure to subscribe. We do the sessions every week, and we'll be doing those special ones around the graphical stuff until the end of December. I also put on chat our LinkedIn profile. Make sure to follow us there. I always create an event for each of the Technical Tuesdays, so you can make sure to get the link there as well. If you like this video, leave a like. That always helps as well. And if you have any suggestions, like I said, we're open to anything. Let us know. Our website has our contact information. You guys can always reach out to me directly as well. And we'll play around with it. I would like to thank everyone for coming. I don't think we have any questions specifically on this, so we'll continue the conversation next week.
See you next week with industrial icons, more images, SVG, imports, and advanced manipulation of vectors.
Yes.
See you next. Bye.
So thank you, everyone. We'll see you soon. Bye-bye.